Let us look at center and circle of curvature. Okay, in the previous session, we have already looked at curvature and radius of curvature. We are given a function y is equal to f of x, a curve. Let's take a point P on the curve. Let its coordinates be x, y. T is a tangent at P intersecting the x-axis at T1. This is the tangent and it is intersecting the x-axis at T1. PC is a normal drawn at P such that PC equal to rho. Remember what is rho? Is the radius of curvature. So let's draw a perpendicular and let's mark the point C, radius of curvature. So C would be the center of the circle of curvature. So now keeping this PC as the radius and C as the center, let's draw a circle. So this is the center and this is the circle of curvature. Okay, now let me just make this go off and let's move this point P and see what happens. See, it is always hugging the curve. So the curve and the circle, they have the same tangent at P. So now what we have to do in this session is to figure out the coordinates of C and the equation of the circle. So let's do that. C is equal to x1, y1. Let's say. Now let's take m equal to x comma y1. So x comma y1 means what? X is the x coordinate of P and y1 is the y coordinate of C. So that is m. So that is this. And n is equal to x1 comma 0 and L is equal to x comma 0. So it is a different way of saying that drop a perpendicular from C to the x-axis. Drop a perpendicular from P to the x-axis. So those intersection points with the x-axis become N and L. Then draw a line parallel to the x-axis through P and take the intersection with this line as M. That's what it boils down to. Now let's join these points. Let's join this, and let's join these points so that we end up with a triangle. Remember, this PC is the rho, that is the radius of the circle of curvature. Triangle PCM is right angled. So angle PCM is equal to 90 degree minus CPM, this angle. CPT1 is 90 degree because this is the tangent and this is the radius. And angle CPM is equal to CPT1 minus MPT1. So combining these two, we get CPM is equal to 90 degree minus angle MPT1. So angle PCM will be equal to 90 degree minus angle CPM. Angle CPM is 90 degree minus MPT1. Angle PCM will become equal to angle MPT1 if we simplify this. Now, angle PCM is equal to PT1N. How did that come about? Now you see MP is parallel to T1L And this tangent is the traversal through these two parallel lines. That means this angle and this angle, they are equal, but this angle MPT1 is equal to PCM. That means angle PCM is equal to PT1N. Okay, let's say this is the center. Now what happens? You notice this is the angle made by the tangent with the x-axis, which we usually mark it as gamma. So since it is equal to angle PCM, we can say PCM is equal to gamma. Figure out the x coordinate of C. What is x1 equal to? So point is C. So x coordinate of C is equal to x1, which is equal to x1 is equal to what? ON. Now ON is equal to x1 is equal to, we can write ON as OL minus NL. So x1 is equal to OL is x and NL is equal to MP. MP is a side opposite this angle. So opposite side by hypotenuse will give you sine. This is equal to gamma angle. So we can say sine gamma is equal to MP by rho. Or we can say MP is equal to rho times sine gamma. So our coordinate of the center of the circle, as far as the x coordinate go, we can arrive at this using this expression. Now let's figure out y coordinate of C. Now that is equal to Cn. Let's again simplify this diagram a little bit. Let me join P and T1 so that I can get rid of that full line. Now Cn can be written as Nm plus Cm. So y1 is equal to Nm is y and Mc is the adjacent side to this angle gamma. Adjacent means cos. So that means MC is equal to rho times cos gamma. So now we have got both x1 and y1. So we have got the coordinates of the center of the circle of curvature. Now we know tan gamma is equal to y prime is equal to dy by dx. So cos gamma can be written as 1 by sec gamma. Why cos gamma? Because here we have this cos gamma, here we have sin gamma. So we are just manipulating that. So cos gamma is equal to 1 by sec gamma can be written as square root of 1 plus tan square gamma. And tan gamma is y prime. So tan square gamma can be written as y prime square. So we have cos gamma is equal to 1 by square root of 1 plus y prime square. Now let's look at the sine gamma. So tan gamma is equal to sine gamma by cos gamma, which means sine gamma is equal to tan gamma times cos gamma. Now tan gamma is y prime and cos gamma is 1 by square root of 1 plus y prime square, which is equal to y prime by square root of 1 plus y prime square. Previously, we have seen in the previous session, rho is equal to 1 plus y prime square to the power of 3 by 2 by the second derivative, y double prime. Now, x1 is equal to x minus rho times sine gamma. So let's do the substitutions. X1 is equal to x minus rho is this. So we substitute it here times sine gamma is this. We substitute and simplifying it, we get x1 is equal to x minus y prime times 1 plus y prime square divided by y double prime. See here in the denominator and the numerator, if we take this denominator top, we get 3 by 2 minus 1 by 2. So 3 by 2 minus 1 by 2 is 1.5 minus half is 1. So that way this doesn't have a power. Okay. Now let's look at the y1. y1 is equal to y plus rho times cos gamma. Again we do the necessary substitutions. y1 is equal to y plus rho is this, substitute, cos gamma is this, substitute it, simplifying it, we get y1 is equal to y plus 1 plus y prime square by y double prime. Here again 3 by 2 minus 1 by 2 gives us 1. So we have got x1, we have got y1. That means we have got the coordinates of the center of the circle of curvature. And once we know the center and we know the radius, that means we know the equation of the circle. So this is the expression for finding the center of the circle of curvature. And this is the equation for the circle of curvature. That was center and circle of curvature. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.